Welcome to Session 2, Object Standards and Object-Oriented Software Process. In this session, we will discuss on Object Standards and Object-Oriented Software Processes and how they support the developments of high-quality object-oriented systems. Object standards are formally guidelines that define how object-oriented systems are modeled, designed, and implemented. Their main purpose is to ensure consistency, interoperability, and software quality across different projects, teams, and tools. By following object standards, developers can create systems that are easier to understand, maintain, and reuse. One important type of object standard is modeling standards. The most widely used modeling standard is the Unified Modeling Language, UML. UML provides a common visual language through diagrams such as use case diagrams, class diagrams, sequence diagrams, and component diagrams. Those diagrams help developers and the stakeholders clearly understand system structures and behavior regardless of the programming language or development tools used. Another category is programming and component standards, which guide how classes, interfaces, and components are designed and implemented. Those standards encourage best practices such as proper encapsulation, clear naming conventions, and component reusabilities. They also support interoperability by defining standard interfaces and communication mechanisms that allow different systems to work together. Object standards also include process and documentation standards, which defines how development activities are performed and recorded. Those standards help teams follow a structured workflow, improve communication, and maintain traceability from system requirements to final implementations. This video also explains the object-oriented software process as a systematic step-by-step approach to developing software using object-oriented principles. The process begins with requirement gathering, where the needs of users and stakeholders are identified. The requirements are commonly documented using use cases which describe how users interact with the systems and what service the system must provide. The next step is object-oriented analysis, where the problem domain is examined to identify key objects, classes, attributes, and relationships. At this stage, developers focus on understanding what the system should do rather than how it will be implemented. Unified modeling language diagrams, such as use case diagrams and class diagrams, are often used to model system behaviors and structures. After analysis, the process moves to object-oriented design, where the system structure architecture is defined in detail. Classes are refined, responsibilities are assigned, and interaction between objects are modeled using sequence and collaboration diagrams. Design decisions related to inheritance, interfaces, and components structure are made to ensure flexibility and reuse. The next step is implementations, where the design models are translated into source code using object-oriented programming languages such as Java or C++. Each class and object is implemented according to the design, following object-oriented principles like encapsulation and polymorphisms. Finally, the process includes testing and maintenance. Objects and classes are tested individually and as part of the complete system to ensure correctness and reliability. During maintenance, the object-oriented structure makes it easier to modify, extend, and improve the system over time. Overall, the object-oriented software process supports the development of robust, reusable, and maintainable software systems. Thank you for watching. In the next video, we will move to Chapter 3, Gathering User Requirements.